With Google Apps Script, you can build web applications and GSuite add-ons right inside your browser using a language that is very similar to JavaScript. In this tutorial, you'll learn how to build Google Apps Script projects locally inside Visual Studio Code. My name is Amit Agrawal, and I've been building web apps and add-ons with Google Apps Script ever since it was launched almost a decade ago. Some of the popular add-ons that I have built with Google Apps Script have 100,000 plus users. You can find them all on my website digitalinspiration.com. Coming back to the tutorial, we'll be writing all our code on our local machine inside Visual Studio Code, and then we'll push it to our Apps Script project with CLASP. Now, Google Apps Script doesn't support modern JavaScript features like arrow functions, classes, destructuring. So we will be using the Babel transpiler to transform our JavaScript code into NES 2015 version that AppScript can understand. Then we'll use Webpack that will help us bundle all our code, including the HTML and CSS files, into an optimized bundle for pushing to the AppScript project. So we are ready to write code, but before we do that, go to the Google Apps Script website at script.google.com. Now here go to settings, and then you need to turn on the AppScript API. Now this is required because the CLASP tool uses the AppScript API to interact with your AppScript projects. For this project, we'll use the AppScript starter kit. Now the advantage of this starter kit is that it requires absolutely no build configuration. So it sets up a local development environment for a great developer experience. And under the hood, it uses Babel and Webpack, but you don't need to know anything about these technologies. So to begin with, I'll copy the Git URL of this repository. And inside my terminal, I'll use the git clone command to create a project that we'll name as Mailman. Now Mailman is a simple web app, and it will also be available as a spreadsheet add-on that will allow us to send emails to anyone via our Gmail account. Our project is now cloned into the Mailman directory, and I'll remove the Git folder so that all the existing Git history for the AppScript starter kit is removed from the Mailman project. The starter kit comes with sample code to help you get started. We will, however, start with a blank slate, and therefore we can remove the src folder as well. Make sure that you have Node installed on your computer. Now Node ships with npm package manager, and that we'll need in the workflow. Next, we'll run npm install, and this will install all the necessary dependencies, including Webpack, Babel, CLASP, Prettier, and all the other required modules. So the packages have been installed, and if I do an ls, you can see that a new folder called node modules has been added to the project. Now we have the CLASP utility installed inside the project folder, and we'll use the CLASP login command to allow CLASP to access our Google account so that we can interact with our AppScript projects. Now if you've not heard of npx, it is a small binary that comes bundled with npm. So what you can do is you can install tools like Webpack, CLASP in the local project folder instead of installing them globally on your computer. So when you run a command like CLASP with npx, it actually looks into the local project bin folder and then executes it. Okay, so I'll press enter here, and it will take me to the authorization dialog in the browser. Now it requires permissions to access my AppScript projects, so I'll click allow, and now I can use any CLASP command on my system. Now if you're not aware about CLASP, you can check their GitHub repository, or you can use the -h flag to get a list of all the available commands that are available inside CLASP. So we are particularly interested in the CLASP create command that will let us create a new Google Apps Script project in our Google Drive. So for this example, we want to create a script that is bound to our Google Sheet. So we'll set the type as Sheets. and the title of the Google Sheet will be Mailman, and we'll set the root dir as our dist folder. So any files that are in the dist folder will be pushed to the AppScript project with CLASP. So the sheet and the associated script has been created. Let me copy this link to the clipboard and open the sheet in the browser. Now this is a blank sheet, and if I go to Tools and under that I go to Script Editor, I can view all the code that is associated with this project. Now this is obviously empty because we haven't written any code yet. So let's quickly write a simple function here. Now let's run this, and if I now look at the logs, you can see that the hello world message has been printed in the log. So for simple projects, you can write your code directly inside the AppScript editor in your browser. But there's one small problem here. So here I have a simple function that uses object destructuring to print the value of name. Now it is a simple function, but it fails because AppScript editor doesn't recognize the syntax that was introduced in ES6. Let's now convert this function into an arrow function. Now this fails here as well, though if you can see, it works just fine in the latest version of Google Chrome. Okay, let's now switch to the command line, and we'll use the code command to open the current project folder inside Visual Studio Code. Now here we'll create a new src folder, and inside that we'll create an HTML folder that will store all our HTML files associated with this project. Now before we start writing any code, open the Webpack config file, and here change the mode from production to none, which is the same as the development mode. So when the mode is set to production inside Webpack, the code is more optimized but less readable and also very difficult to debug. So what we do is when we are in the development phase, we set the mode as none, and when the development is complete, we switch the mode to production and then push our code to AppScript editor. Next, we need to open the manifest file, which is called appscript.json in our project. Now here we don't need the Google Drive service, so we'll get rid of it. If you're making use of third-party services like Twitter or Facebook, you probably need these OAuth libraries, but we won't be needing them in this simple project, so we'll just get rid of them as well. Next comes the most important section that defines the authorization scopes that will be used by your project. Now our app will send emails, so we need the Gmail send scope. We don't need to read the body of Gmail messages, so we can get rid of the Gmail read-only scope. I'll keep the settings scope because I need to know all the aliases that are connected with the Gmail account of a user. The Drive service is obviously not required. This Google script will not make any connection to an external web API, so we don't need this scope as well. Now in some cases, the Gmail service may be disabled for a domain, but they can still send email inside AppScript using the built-in mail app service of AppScript. So we'll try to keep this scope because in case if Gmail is disabled, they will still be able to send emails. Storage is not required. We are not reading data from a spreadsheet, so access to the spreadsheet data is not required. We also don't need access to users' email. The container UI scope is required since we'll be showing this app inside the sidebar of our spreadsheet. Now before we switch to the code, if you're wondering where these scopes are coming from, I'll show you a quick trick. So you go to the Google Auth playground and just find it on Google. So here you see a list of services that are available inside Google, and let's expand any service. Let's take the Gmail service, and here you get a list of all the scopes that are available for that service. Okay, let's write some code now. So we'll create an index.js file in this src folder. Now let's try to replicate the same hello world function that we initially created inside the AppScript editor. After we are done creating the function, we need to add this function name to the global object so that it becomes available as a top level function inside AppScript. Now this is a requirement of the Webpack plugin for Google AppScript. Next we'll run the build command to transpile this code into a version that AppScript can understand. And just keep an eye on this project tree. So as soon as you run the command, it creates a dist folder. Now it has two files. It has the bundled code and it has the manifest file. So next what we'll do is we'll run the CLASP push command. Now what this will do is it will send the files from the dist folder, which is the root dir folder, to our script project. Now if we switch to the script editor and reload it, you can see that all the code is now available inside the AppScript project. I can also go to the view menu to see the manifest file that we have written inside Visual Studio Code where all our scopes reside. Okay, so the code is here. Let's see whether the code works or not. So we'll run the hello world function again. Now this requires authorization as we have added several scopes to the project and we need to allow access to these scopes before the execution can proceed. So the execution is complete and I can see that the new function works just as expected. Now let's go back to Visual Studio Code and make another small change in our code. Now instead of manually running CLASP, I'll show you a couple of npm commands that are included with the starter kit. So if I go to the package.json file and navigate to the scripts section, you can see a build command that transforms your code with Webpack. And then there's the upload command that pushes the code to the AppScript project with CLASP. And then you have the deploy command which runs both the previous commands in sequence. So essentially to transpile the code and upload the code to AppScript project, I can directly run the deploy command rather than running these two commands separately. Okay, let's now write the HTML file that we'll show in the spreadsheet sidebar. We will be using the materialized CSS library that creates a responsive layout and that follows the material design patterns, so your UI would look really beautiful with very minimal code. Now to use material design, all you have to do is add the relevant CSS and JS files from the CDN in the head of your index.html file. We'll also add the jQuery library to our project because that makes it easy to pull the form data and send it to the server. Visual Studio Code has a built-in beautifier, so you can use that to quickly format your HTML code. I have a little extension called Live Server installed inside Visual Studio Code. So what this does is it opens the preview panel, and while I'm coding HTML, I can see the live preview of that on the right side of my screen. So we are using Emmet here, which is again baked into Visual Studio Code, and with Emmet you can quickly write HTML blocks using simple abbreviations. So we are adding a form to our HTML, and when someone submits the form, we'll execute the send mail function. First we'll write the HTML code and then we'll worry about the JavaScript part. So first we'll add an input field, and this is for getting the recipient's email address. The next input field is the subject line. And for the email body, we'll use the text area element. And the difference between an input field and text area element is that in the input field, everything goes in one line, whereas in the text area field, you can have line breaks, you can press enter and have multi-line text inside the text area. Let's also add one select field in our form, and this will be a drop down where users can pick the Gmail alias through which they wish to send their emails. Now if I look at the HTML preview, you can see that the drop down is not appearing. So let's look at the documentation of Materialize CSS to see why this is the case. So here it says that you need to initialize the select field for it to show in your document. So let's do that now. Okay, it looks good now. Let me move the script to the document head, and I'll now add the send mail function that will be called on form submit. Now this will be a very simple function that will simply take all the input field values and then create an object. So the object is ready. Let's write an alert statement to test if the function is correctly capturing all the values. Okay, this looks good now. We'll make use of the Google client-side API to send this form data to the server asynchronously. We can use the with success handler method to set a callback function that will run when the server-side function returns successfully. Now this Materialize library has this nice toast method that displays these nice notifications, and we'll use these in our callbacks to indicate the return status. I will make some more changes in the form. So to prevent users from submitting the same form multiple times, what we'll do is we'll disable the button while the server side code is in execution, and then re-enable it when the execution is complete. So our HTML file is done. Let's now create an onOpen method, and this will be called every time the user opens the Google Sheet, and we'll use this method to add a nice menu to our Google Sheets from where they can run our mailman utility. Now if you just notice, the spreadsheet app service is actually an AppScript service, and yet VS Code could offer intelligent autocomplete suggestions for that. And the magic behind this is the TypeScript definition files that are automatically installed in your project through the package.json file. So coming back to the menu, we can also add emojis and other special characters to the menu name, And these visual hints help because the user can quickly find your custom menu in the Google Sheet. We'll also add two items to our menu. One will be for opening the sidebar and the other one for showing the credit screen. Okay, so this menu code is ready. Let's now deploy this to our project using the npm deploy command. So if I reload the code on the server side, you will notice that our newly created onOpen method is not available here. Can you guess why? Well, the answer is simple. To add any top level function, you need to add it to the global object as well. So I'll go back to my index.js file and first import the onOpen function and then add it to the global object. Let's try deploying the code again. So the new onOpen method is now available in our code, and if you reload the Google Sheet, you can see that a new menu has been added. If you try clicking any of the menu items, they will obviously not work because we haven't written the corresponding functions yet. So let's do that now. One little thing I forgot to include in our index.html file is the list of Gmail aliases for the dropdown. So we'll make use of scriptlets here, and these are special tags that let you write AppScript code inside HTML files. More on this later. Next, we'll create a new function to show the sidebar inside the spreadsheet. I think a better name would be show sidebar. So we'll use the handy rename feature in VS Code to rename all occurrences of this symbol. Remember, we added the aliases variable inside the scriptlet inside the HTML file. We need to assign the list of aliases now to that variable. Now I can either assign the aliases here or maybe create a new separate function that we can reuse later in other modules as well. Now this is the old way to get all the email addresses of a user, but since we are writing code in modern JavaScript, that is ES6, we can make use of the spread syntax, which produces shorter code and cleaner code. So you'll assign the aliases variable to the function that we just created, and you'll notice that VS Code will automatically import the required modules. So this is another time-saving feature inside VS Code. So let's now compile the code and upload the changes to the AppScript project. So it failed again, and that's because we forgot to add the show sidebar function to our global object. and it finally works now. So the form works, but we can't test this yet because we haven't written the send mail function on the server side that will actually send the emails. So we'll write it now. Now the first argument of this function is an object that includes all the input fields. We can make use of object destructuring to get all the field values inside separate variables. We'll enclose this send mail function inside a try catch block, because if the Gmail service is disabled for a user, they should still be able to send emails using the mail service of AppScript. We are using templated strings here to concatenate strings, which are again a feature of ES6. Let's also add the sendMail method to the global object so that it becomes available to the Google Script client API. Now you may have noticed that we haven't added the getGmailAliases function to the global object, and that's because it's being called by one of the top level functions, but the users need not run it directly. Okay, all set. Let's test the changes now. So we get a nice notification saying that the mail has been sent. Let's see that in Gmail. So the email has been sent successfully. It's showing up in the sent items, but I think we goofed up somewhere because the email address is also showing up in the subject line. I think that should be easy to fix in the index.html file. Okay, so our spreadsheet side is nearly complete, and let's now publish this script as a web app so anyone can send emails without having to open the spreadsheet. We'll go to the script editor and then deploy this script as a web app. Now this provides us a URL, and this is actually the URL where our web app will reside. So anyone can go to this URL, authorize the app and send emails. However, if I open this web app now, it shows an error. And that's because we haven't written the doGet method, which is required for rendering web apps. Now the doGet method will be very similar to our show sidebar method, so I can just copy paste some code from there. And we also need to add the doGet method to the global object, and then we can upload the changes. So it works. So let's now test the web app as well. Perfect. So our spreadsheet add-on is working and our web app is also working. So what we'll do is we'll go back to the Webpack config file and change the mode from none to production. I'll show you one more time-saving feature of Visual Studio Code here. Now instead of going to the external terminal for running npm commands, we can use the VS Code menu to directly run npm script inside the editor itself. Also, this is specific to building web apps inside VS Code. Now, when you make any changes to your app script code and you have published that code as a web app, you also need to deploy the app again with a new version. Now, we can make use of the CLASP deployment command to get a list of all IDs of the web app that we just deployed inside the app script editor. Now, these are the list of IDs, and if you have to deploy the web app again, we can make use of the deploy command and then use the -i flag to pass the ID of the existing project, and it will be redeployed with a new version. Now you will have to do this every time you make changes to your code. So what you can do is, to save time, you can add this command to your script section of your package.json file. And your project will be automatically redeployed with a new version every time you push any local code to the app script project. So let's now test this by making a small change in the index.html file. And let's publish the changes. And you can see that the change is now instantly available both in the spreadsheet add-on as well as the web app. So the code is nearly complete. In the next section, we'll push our code to GitHub. So let's first create a new repository. You can create a public repository or even a private one. Now I'll switch to the project root folder and then run git init to initialize the repository. Then we'll say git add to add all the files to the staging area. And finally we commit all the files to the local repository with the git commit command. Now when you use git commit, the files are actually in your local repository, but they're not in the GitHub repository yet. So we'll make use of the git remote add command to send the URL of the remote repository. Next, we push all the changes to the repository. If you go to GitHub, you can see that all our source code is now available here. So you've seen how easy it is to build Google Apps Script projects locally using Visual Studio Code and the Apps Script Starter Kit. I can't wait to see what you build with this. And if you ever need help, here are all the different places on the internet where you can find me. Thank you.